Hello everyone. So this is the tricky integral, indefinite integral that I was supposed to solve at question number 3 on my final exam. What the fuck? Now, okay, good. And quickly, I just want to note that please check out the link in the description. I do coaching calls. Anyways, so this thing here. Okay, what the fuck do we do? Okay, so we have x over the square root of x to the power 4 plus 4x squared plus 8. A very suitable substitution would, of course, just be u is equal to x squared, one might think, because then so this would just be 1/2 times the inner derivative, or just the derivative. And okay, so here we just have would have u squared and u. So okay, yeah, that kind of makes sense. It would make things look a bit simpler. So then we would have, 1/2 times the integral of du over square root of. So then it would just be u squared plus 4u plus 8. Okay. And if you're really good at integrals, then you would look at this and think, oh, arc hyperbolic sine. Well, anyway, that's the way we're going. Okay, so now either if you want to do some kind of hyperbolic sine, or you just want to be able to use arctan or anything like that, we don't want this u term here, so we want to group this up. So this thing down here is obviously just u plus 2 to the power 2 plus 4. So therefore we make the variable substitution. So we have our new letter t. Okay, so we want 2 times u plus 2. No, fuck. I'm so sorry. Divided by 2. Divided by 2. Yes, exactly. Because then we would exchange this for 2 times t to the squared, thereby meaning 4t, and then we can extract the 4. So, meaning that dt du is equal to 1/2. So then it would be 1/2 times the integral of, okay, so what was, okay, du is equal to 2 times that. So then, okay, the 1/2 would just disappear. And then we will have dt over the square root of, okay, and then we would have, okay, so we would have 4t squared plus 4, so then we can extract the 4. Square root of 4 is 2. So then we would still have a 1 over 2, and then the square root of t squared plus 1. And here, now, when we're at this point, if you're really good at integrals, you would just see that this is the arc hyperbolic sine of t, and you would also get the same thing if you were to try to use the hyperbolic identity, that hyperbolic cos squared minus sine hyperbolic squared is equal to 1. Then you would essentially get the same thing, because when you try to change this for a sine, hyperbolic sine, well, yeah, you have to do the inverse, right? So you have to do that, okay, t is equal to hyperbolic sine of our new variable, and then you would just realize that the derivative is exactly what you have here. So this is what you should do. What I did instead was some stupid fucking imaginary substitution, so I got like, yeah, I think it became like minus I times 1 over 2 times arc sine, arc sine of it. And this turns out to be a completely real function. It has no imaginary part because it's exactly the same as if you would do the hyperbolic sign substitution, or just it's just a solution. It turns out to be exactly the same thing, which is kind of cool. And I cannot prove this, but I can show, or maybe I could, but I'm not going to prove this. But one way you could think about this, or showcase it, maybe you could say, is the fact that the Taylor polynomial for arc sine of t only contains odd exponents, right? It only has like x and x3 and x5 and so forth. So therefore, if you take this thing to an odd power, you always have an I left. And then when you multiply it by another I, all the i's disappear. So therefore you get a completely real function. So yes, this is what you were supposed to do. So therefore, what would you get? Okay, well, this is just a quick side tangent. So what would you get then? Okay, we'll just get that this is equal to 1 over 2 times arc hyperbolic sine of t, which was equal to u over 2 over 2. So that's just u half plus 1. And then u was equal to x squared, right? So what we would just get is that, okay, we put an x squared over there. So this would just be 1/2 times arc hyperbolic sine of x squared over 2 plus 1. So, and that is our answer. And there turns out to be multiple ways to do this. He did it in some other way with just a bunch of fucking ln's and square roots and shit. But so yeah, if you find another solution, please let me know. And so yeah, and plus c. Jesus Christ. Jesus Christ. Plus c. Fuck. Rule number 1. And I almost broke it. Damn, that was scary. So yeah, we are done. And thank you so much for watching. And now on to problem number 4.